Introduction to IoT No2 Practice on the easiest remote control devices. Sequential control systems by RaspberryPi. We divide the processes of manufacturing into small units, check each unit, and correct any defects immediately. It is easier to find the misconnections compared with at the state of the whole device is assembled. RaspberryPi is a microcomputer developed for IoT education. The image captured by the digital camera via Raspberry Pi is projected on the screen of the Raspberry Pi, and the image is displayed on a remotely controlled computer also. So, taking a look and control the Raspberry Pi from the computer. Raspberry Pi has general-purpose input-output GPIO, to which hardware such as sensors and actuators are built in the system. As shown in Fig. 1, the Raspberry Pi is basically used by connecting a display, keyboard, and mouse. The price of the Raspberry Pi 3 Model B single-board computer is about 10,000 yen. 7-inch monitor for Raspberry Pi is also about 10,000 yen. In addition, you will need a microSD card 32 GB, keyboard, mouse, HDMI cable, and USB cable. The total cost of the system is at least 30,000 yen. The detailed descriptions are written in many books. The author recommends the book, Learn by Running with Python. New IoT Textbook, by Koji Sakamoto, Shueisha, 2020. Operating System of Raspberry Pi. IoT has a function of the remote control by a network of computers that share communication lines. In a computer network, IP address formatted by TCP, IP Transmission Control Protocol, Internet Protocol is added to the beginning of the information to be transmitted. The entrance to Internet system has a router that controls the distribution of information. Routers have the memory that hold data and decide whether or not to receive it. Raspberry Pi Operating System OS. The Raspberry Pi's OS is downloaded from the Internet to a computer and copied to a microSD card. The SD card plays the role of a hard disk in the Raspberry Pi. Insert the SD card with the OS into the slot of the Raspberry Pi. And connect your display, keyboard, and mouse. When you power on your Raspberry Pi, it will install automatically. Initial Raspberry Pi setup. During installation, on the Change Password screen, enter the password you want to set in, enter new password. Select the Wi-Fi network you want to use on the Select Wi-Fi network, and enter the Wi-Fi password on the Enter Wi-Fi password. Settings for operating the Raspberry Pi. There is Visual Network Computing, VC, in the software to remotely control the Raspberry Pi from the computer. First, select the Wi-Fi network of your computer and Raspberry Pi, and enter the same Wi-Fi password. Since the Real VNC software is installed on the Raspberry Pi OS, click the icon in the upper left corner of the Raspberry Pi desktop and select Raspberry Pi Settings in the Settings menu to enable SSH and VNC. SSH Secure Shell is a standard for encrypted communication for secure remote control of devices connected to a network. From the desktop menu, you can select LX Terminal under Accessories and enter commands into the Raspberry Pi as if it were a command prompt on a computer. If you need to specify the IP address of the Raspberry Pi, check the 1P address on the screen displayed by the command $IP ideographic period. How to access the Raspberry Pi from a computer. Download the SSH-enabled terminal app, Teraterm, start the installed Teraterm, and enter the IP address of the Raspberry Pi in host. Next, install the RNVC VNC software on your computer. Double-click the downloaded installer to launch VNC Viewer Setup and follow the instructions to install it. Double-click the VNC Viewer icon on your computer to launch it, and Get Started with VNC Viewer will be displayed for the first time, so click Got It, and enter the IP address of the Raspberry Pi on the VNC Viewer that starts. Click Continue, and enter username and password at the beginning of the authentication. In this way, the screen of the Raspberry Pi desktop is displayed on the computer display and a remote control system is built. Tools for programming. Programming uses various tools as shown in Fig. 2. The Integrated Development Environment (IDE) is a collection of software such as editors, compilers, and debuggers that write code. Graphical User Interface (GUI) is software that allows the user to perform the desired operation by pointers displayed on the screen. General Purpose Input/Output. GPIO is input and output terminals of Raspberry Pi. GPIO consists of two rows of pins on the right side of the board. The left side is odd-numbered, the right side is even, and the right is numbered from top to left, and right is numbered downward. As shown in Fig. 3, the reference potential 0 volt is set to terminals 6, 9, 14, 20, 25, 30, 34, and 39. 3.3 volt is supplied from one terminal, and 5 volt is supplied from 2 and 4 terminals. Characteristics of LED. The electronic circuit for LED needs a load resistor. The LED will not light up unless a voltage of 1.8 volt or higher is applied. However, if a voltage of 2.1 volt or more is applied, the current will flow too much, and the LED will be destroyed. Therefore, a load resistor is connected in series with the LED. Since LEDs emit light with a current of about 2.5 mA, resistors with a resistance value of 470 ohrm is connected in series. There is the LED that can be directly connected in parallel to the 5-volt power supply terminal. The LED with a built-in 5-volt dedicated resistor is very small, but you can see the resistance inside. An example of the Python program that controls the lighting of the LED. Python is a simultaneous interpretation type programming language that is called and executed one line at a time. Click the Raspberry Pi icon in the upper left corner of the desktop and select Thonny Python IDE under Programming from the menu to write the program. When you have finished writing the following program, click Save. Memorize the file name, LED on off. Then, click the Run button to turn on the LED. In LX terminal, type Python LED on off.py, and the LED will light up again. The program that gets data from a temperature sensor. In the interface of the Raspberry Pi settings, enable I2C by Shift on the right side, and connect a temperature sensor ADT7410 with the GPIO of the Raspberry Pi. The pin connections are VDD equals 3.3 volt equals 1, SDA equals 3, SCL equals 5, GND equals 6. The program shown in Fig.6 is quoted from Learn by Running with Python. New IoT Textbook, by Koji Sakamoto, Shueisha, 2020 p.73. DC motor drive circuit controlled by Raspberry Pi. DC motor generates a large amount of current when it starts moving. Therefore, if the power supply of the DC motor is connected directly to the Raspberry Pi terminal, the power supply voltage will fluctuate when the motor starts, and the Raspberry Pi will behave abnormally. Therefore, Fig.6 shows a circuit in which the activation of the DC motor does not affect the Raspberry Pi and operates on-off. This circuit can be connected to a DC motor instead of an LED using the program that controls the LED lighting in Section 7 to check the control operation. A program that drives a servo motor. Servo motors are used to control the angle of the rotation axis. Pulse width modulation (PWM) programmed in Raspberry Pi is used as input to the servo motor SG90. The DA conversion is performed inside the servo motor, and the specified angle is maintained by feedback control. The output of PWM can be checked by the change in the brightness of the LED. How to get image from Pi camera through Bullseye lib camera mode. How install the OS of Bullseye. Install the Raspberry Pi Imager on your PC and write the 64-bit OS of the Raspberry Pi V4 to a microSD card. Plug that microSD card into the Raspberry Pi V4 and it will start the install automatically. Then follow the instructions on the screen. Do an update along the way. The latest version of the OS is Bullseye, in which the camera driver, libcamera, is installed as standard, and there is no option to enable the camera on the Raspberry Pi interface setting screen. How to use the V2 camera with Raspberry Pi Model 4. That is carried out by click, run, and command, libcamera hello T0. So it will display the image of the camera. Summary. The conventional automatic control by feedback loop is complete by itself as a closed-loop control. Raspberry Pi is possible to form a system with remote control. The image sent from the digital device can be used as the data to judge next behavior. The sequence control system opens to the outside world. Although the IoT system responds to various situations with human involvement, the device itself is simple compared with feedback controller. Thank you for your attention.